Right, good morning, grade 11s, Monday 11th of May. After we have now completed the hyperbola and the exponential function, how to draw it, we're going to do the opposite today, and we are going to have to find the equations given to us by giving you the sketch. So what am I going to have to look out for? Well, first of all, you need to be able to find the difference, or what is a hyperbola, what's an exponential graph. If we start with the hyperbola, you first need to know what is the formula. And the formula of a hyperbola is y is equal to a over x plus p plus q. What do I start with? Step 1, I'm going to read off the two asymptotes, which means I'm going to determine the value of p and q. After that, the only variable left to find is a, and then to find a, I will just substitute a point. So if I look at the first example on page 21 in your notes, I can see that I have two asymptotes given to me, and the one is at y equals 1 and the one is at x equals 2. So when I do write my equation, instead of writing plus 2, I'm going to write minus 2, and I'm going to have my q value of 1. How do I determine a? I am going to substitute a point. That point is given to me, 4 and 3. So 3 is equal to a over 4 minus 2 plus 1. The plus 1 goes over, becomes a 2. 4 minus 2 is 2, and a works out to be 4. So my equation for this function is 4 over x minus 2 plus 1. Very, very simple. B, this is also a hyperbola. I see there's my one asymptote, there's my next asymptote. So all I know is x equal to minus 1 and y equals to 0 is my asymptotes. So when I write my equation for a hyperbola, instead of writing minus 1, I'm going to write plus 1, and then I don't need to write the plus 0. It's not going to make a difference. The only variable now to find is a, and how do I find a? I substitute a point 0 and minus 3, so I am going to have a is equal to negative 3, so my equation is minus 3 over x plus 1. And that correlates with my graph given to me because it is drawn in quadrant 2 and quadrant 4. That mimics a negative hyperbola. So when I look at number C given to me there, now I'm first having to go to page 2, there we go, determining the equation of a exponential graph, that's on page 22. So I need to know the general formula of an exponential function is a times b to the power of x plus p plus q. Out of the four unknown values, a, b, p, and q, you will have to determine 2 or 3 of the 4. What is my first step again? Asymptote, the q value, and then I'm going to substitute points. Now you will see that if I have one variable left after I substituted q, I will substitute any point to find it. If I have two variables that I have to find, I will have 2 points. And if I have 2 points, it means simultaneous equations, which means I'm going to use both points, substitute them. In one of the substituted ones, it will take care of one of the variables in order for me to find the next. But we'll do that in the examples. Okay, so if I look at the first example, I see that I have an asymptote at y equals to minus 4. So they also specify the equation you are working with. So in plus, instead of plus q, I'm going to write minus 4. That means I only have one variable left to find. And if I have one variable left to find, I substitute a point. So 5 is equal to b to the power of 2 minus 4. Minus 4 become plus 4 on the other side. So 5 plus 4 is 9. And I can write that b is 3 because 9 is 3 squared. So the equation for this function is y equals to 3 to the power of x minus 4. Very straightforward and easy. If I look at the next one, I have an a and a b. They already know that my y asymptote is 0. Okay, so that's not of any importance. But I have two variables, which means I will have to substitute both points. So I have y equals a times b to the power of x. I'm basically going to have two sums. I'm going to substitute minus 1 and 6. And I'm going to substitute 0 and 3. So I have 6 is equal to a times b to the power of negative 1. Now I can't solve an equation if I don't have one variable. But if I substitute 0 and 3, I'm going to have 3 equals a times b to the power of 0. Now what do I know about b to the power of 0? It is equal to 1. So a will take up a value of 3. So I'm going to take that back into my first equation there, and I'm going to say 6 is equal to 3 times b to the negative 1. So divide both sides by 3, and b to the negative 1 is as good as me saying 1 over b. That means after I've done my algebra, times by b on both sides, divide by 2 on both sides, b works out to have a value of a half. So the equation for this graph is 3 times a half that is raised to the power of x. Okay, so that's a standard exponential function, finding the equation. I can go and try and make your life harder. Okay, I just want to cover this. Right, so what happens if I now give you a bit of a challenge? So when I look at this, I have 1, 2, 3 variables that I need to take care of. Okay? Q, I can read off minus 1, minus 2. I see that they have given me the asymptote as minus 3. So y equals b to the power of x plus p, and q can be replaced with a negative 3. It still leaves me with 2 variables, which means I am going to have to substitute 2 points. I'm going to substitute 0 and minus 1, but I'm also going to substitute 1 and 1. So if I substitute 0 and minus 1, I get minus 1 equals 0 plus p is just p, and q has a value of minus 3. So b to the power of p, minus 3 goes over, becomes plus 3 is equal to 2. 2 variables in one equation, I can still not solve it. I need more. If I substitute 1 and 1, I will have 1 is equal to b to the power of 1 plus p minus 3. That means that b to the power of 1 plus p is equal to minus 3 goes over and equals 4. So what have you learned with exponents? If I multiply the same base, I am going to times the same base. So I can say b times b to the power of p, b to the 1 times b to the power of p is exactly that, is equal to 4. But what do you notice? B to the power of p is equal to 2. So b times 2 is equal to 4. So b is equal to 2. Now, if b is equal to 2, I can take any one of these equations. So if I take b to the power of p equals 2, but b is equal to 2, so 2 to the power of p is 2, what can I say about p? P will have a value of 1. So my final equation here, b has a value of 2, p has a value of 1, and q has a value of minus 3. Not that bad. That's the toughest one I can give you to solve. Right, so what are you going to do now? You're going to do homework, exercise 8 on page 23, A to F, and that is finding the equation of hyperbolous and exponential functions. I hope you have a lovely time doing this. Miss you. Bye.